Hello students, in this video we'll use algebraic properties of functions to show that two limits exist. Our first example will be to show that the limit as x approaches 1 of 1 over x minus 1 over x minus 1 exists. Now note that as x goes to 1, the denominator is going to 0 and the numerator is also going to 0. So this limit looks like I have a 0 over 0. So just as a note, just plugging in gives 0 over 0, which is an indeterminate form. However, let's algebraically modify this function. What I'm going to do is, as x goes to 1, the limit implies automatically that x is not allowed to be equal to 1 when we do limits. So what I'm going to do is I'm going to multiply the top and bottom by x. So 1 over x minus 1 over x minus 1. If we multiply the top and bottom by x, that won't affect anything. And so that will be what? That's going to turn to an x. That's going to turn to a 1 minus x over, and then I'm going to have an x squared minus x. And now what I can do is I can write this as 1 minus x over x times x minus 1. And now since x is not allowed to be equal to 1, I can cancel out these terms over here. This term and this term are opposites of each other, so this is just going to be negative 1 over x. So as long as x is not equal to 1, this expression simplifies to negative 1 over x. So hence, the limit as x approaches 1 of 1 over x minus 1 over x minus 1 is going to be the same thing as the limit as x approaches 1 of negative 1 over x. And now I can actually just plug in 1 now and I get a negative 1. So this limit value is negative 1. Let's see another example of something similar to this. Let's show that the limit as x approaches 4 of the square root of x minus 2 over x minus 4 exists. Okay? Again, note we cannot plug in x equals 4. Note, we can't plug in x equals 4, because for limits, we know that as you're taking a limit, the formal definition of a limit means that this implies that x is not allowed to be equal to 4. Okay? Good. What I'm going to do now is I'm going to algebraically manipulate it. So the square root of x minus 2 over x minus 4. What I'm going to do is I'm going to multiply the top and bottom by x plus root x plus 2 and then root x plus 2, which is the conjugate radical of the numerator. And what I'm going to get is the following. So I'm going to get root x times root x, that's going to be an x. I'm going to have a negative 2 root x and a positive 2 root x, and those will cancel out, and then I'll have a negative 4 over x minus 4 times the square root of x plus 2. And now, just as before, we see there's a cancellation. This will cancel with this, because they're exactly the same, and so our expression is exactly equal to 1 over root x plus 2. So now we can compute our limits using algebraic properties. So therefore, the limit as x approaches 4 of our expression, root x minus 2 over x minus 4, is the same as the limit as x approaches 4, since x is not allowed to be equal to 4, of 1 over the square root of x plus 2. And now I can actually just plug in, and so I'm going to get 1 over the square root of 4 plus 2. Of course, root 4 is also equal to 2, so this is going to be 1 over 4. So that is our limit. Thank you very much.